Well, I promised you it was going to be about sums, difference, products, and quotients of functions, and here it is. So if you have two functions f and g, if you just take f of x and add to it g of x, we use the notation f plus g of x. This is creating a new function. The new function is f plus g. And then we say, what is f plus g of x? By definition, it's just f of x plus g of x. It looks like we're doing a distributive property. We're not. This is just sort of a way of defining what this means to begin with. Similarly, if I have functions f and g, I can make a new function f minus g. How do I plug x into this? I do f of x and I take away g of x. And we're not doing a distribution of the x or anything like that. This is just by definition what this means. And it's called the difference function. Similarly, the product function f times g is just f of x times g of x. The quotient function f over g of x is f of x over g of x. Since we're dividing by something, we had better not be dividing by 0. Okay, so let's work through a collection of examples. Suppose f and g are given as the following. F of x is 2 over x plus 3. G of x is x over x minus 4. Can you find all four of the following? F plus g of x, f minus g of x, f times g of x, f over g of x, and determine the domain. Okay, so work through these, pull out a piece of scrap paper, try to simplify them all down and determine the domain, and then we're going to come back and work through them. So I'll pause here. All right, so hopefully we've gone through them all and we didn't just skip ahead. What's f plus g of x? By definition, remember it's f of x plus g of x. There's f of x plus g of x. They were given on the previous slide. If we give them a common denominator, it'll be x plus 3 times x minus 4. So this first term gained in x minus 4. This second term gained in x plus 3. Now I have a common denominator, so I can just distribute this out as 2x minus 8 and add to it x squared plus 3x, which simplifies as following. Now the domain, it has to be in the domain of f, and it has to be in the domain of g, which means I can't divide by 0, so x had better not be -3 and x had better not be 4, otherwise we're fine. Part B, f minus g, same f, same g, which means it's the same common denominator. Okay, so not a whole lot changes. The only thing that changes is we're going to be subtracting this, so we end up with some subtraction here. But the domain is actually exactly the same. Okay, because we have the same quotients going on, those are our same restrictions. Okay, if you didn't do this simplification of pulling out this minus sign and left it like this, totally fine. This is actually how I would prefer to leave it. Just because I, personally, if I pull minus signs out of fractions, sometimes if I'm writing quickly, they get kind of lost, and then I start making mistakes. So I would tend to prefer writing it like this. I'm less likely to make a mistake like that. That's just me. But anyway, the domain is the same because we have the same restrictions, don't want to divide by 0, and our denominator hasn't changed. So the domain hasn't changed either. All right, f times g. Well, there's f of x times g of x. That's pretty straightforward, and the domain is exactly the same because we actually get the same quotient here. I shouldn't say quotient, the same denominator. So all x's other than -3 and 4. Part D, f over g. Okay, if I do f of x over g of x, we get one fraction over another, which we can simplify by reciprocating that bottom fraction. And we get the following. But what's the domain? This is a little interesting. Okay, f of x over g of x, we don't want to divide by 0. Now, if you looked here and said, I don't want to divide by 0, you'd say, okay, x can't be 0 and x can't be -3, and you'd call it a day. However, the book says we also exclude x equals 4. Why is that? Because back here, x equals 4 is a problem. If you have fractions within fractions, and you do this sort of simplification, your domain restriction is going to be any fraction that ever occurred in the earlier step. Okay, so we can't divide by -3. We can't divide, x can't be -3 because of this. X can't be 4 because of this. But x also can't be 0 because then overall this denominator would be 0, popping in there. So in this example, we actually have 3 points that we have to exclude: -3, 0, and 4. Okay. and a lot of people would miss this one here, but it was built into the domain restriction of G, which means it's carried through. Okay, so that's it for section 1.